Hello. Welcome to another tutorial for Mass. In this video, we'll build a physics-based composition and explore the available physical controls. For this tutorial, I've already set up a synth in my DAW, and I have Mass's pitch quantizer set to C pentatonic with a note range of C3 to C6. Let's add a part and jump into some basic settings. I'm going to disable the trigger event for this part. We won't be using any note patterns in this composition. To give a part a velocity, drag the controller handle in any direction. The further the handle is from the center of the controller, the faster the part will move. This control updates continuously while playing, always reflecting the part's current velocity. Let's hit play and see how this part reacts. Now that we've got a moving part, let's configure it to generate note events when it hits a wall. Like the pattern trigger, we can freely choose any event type for this. We can individually enable event generation on wall and part collisions. They will both generate the same event configured below. Things get really interesting when we have interactions between multiple parts. So let's add another one. I'm going to add a new part and configure it to transpose the composition each time it hits a wall. Like the first part, I'll disable the trigger event so that we're reliant on the physics for all events. I'm also going to enable the continuous event for my second part. Continuous events update constantly while the transport is running, which makes them great for sending MIDI CC. I want this part to control the portamento time and stereo panning for my voice. Let's add one more part and set this one to play note events when it collides with other parts. This one is going to trigger a different voice that I've set to receive on channel 2. Now it's time to see how mass and resistance affect part physics. Every part is capable of moving at the same top speed. The mass control determines how much energy is required to reach that speed. Parts with lower mass are easier to move, while parts with higher mass tend to keep their momentum. Let's reduce the mass of our first part and raise it on the second part to see how it changes their interaction. You can see how different mass values create very different relationships between parts. With higher mass values, you can create compositions that evolve more slowly. With lower mass values, you can create compositions that are more chaotic. Experiment with different combinations to dial in the kind of evolution you want. When you want to really fine-tune the speed of evolution in your composition, experiment with resistance. Resistance creates a drag on a part's movement, gradually slowing it down over time. With a resistance value of 0, a part can move forever. As the resistance value is raised, the part begins to slow down more quickly. Let's see an example. Notice how the parts glide to a stop now? This is a really powerful tool for controlling composition evolution. You can probably spot the problem we've created here. Because of the resistance I added to our parts, the composition fizzles out. This isn't ideal, but luckily we have some tools to keep things active. I'm going to add another part, but this time we'll configure it to be a motion generator. The first thing I'll do is set the trigger event to be an impulse. Impulses are a special type of event that generate physical forces. When impulses fire, they push other parts away from them. This is a great way to control the flow of motion in your composition. I want this impulse to always generate from the center of the composition, so that other parts are pushed towards the edges. For that, we can utilize our axis restriction controls. See the directional arrows in the controller. Tap those to toggle movement in the respective axis. In this case, I don't want the part to move at all, so I'll disable both the X and Y axis movement. Now that we have a central repeating impulse, we don't need to set initial velocities on our parts anymore. You can reset a part's velocity at any time by double-tapping any empty space in the direction controller. Let's look at one last example of how to utilize the physics system. I want to add several parts that will act as obstacles in the composition. Instead of firing events, these parts will create more interest simply by being in the way. I'm going to add 4 more parts. Each part will only move in one axis, and all events will be disabled. Let's place the parts so that they constantly bounce off our impulse generator in the center. Now we've built out an interesting, organically evolving composition using the physics tools at our disposal. It's time for you to go experiment with it and see what you can do. Thanks for checking out this tutorial on the physics system in mass. If you have any questions, let us know in the comments.